Hi, welcome to video 6 in lesson 2, where we will talk about the transformation module in Leap. In this video, I will introduce you to the transformation module in Leap, which is one of the 3 main modules, not counting for key assumptions, which is demand, transformation, and resources. Then I will also talk about how to set up the transformation sectors. We will not be covering, in this case, district heating, nor will we be covering electricity, because that will come in lesson 3, because then we will be talking about optimization. Here we're going to talk about more simple transformation sectors. The first thing we have to do is we have to enable the transformation module and also incidentally the resource module. As you can see right now, we only have the demand module enabled. So that we do by going up to the settings and then into scope and scale. The first one in scope, the transformation and resources, we just take that on. So far we're not going to do anything else, and you will see now we have both transformation and resources added to our list of modules. Now under transformation, we have different transformation sectors that we will now dive into. Okay, so here we have the transformation module. Just a review about that. There is some standard text, of course. We're not going to use much of that because it is just a category or folder so far. So what does the transformation module actually do? Well, it's quite within the name, but it does transform fuels from one to another. So what it does the transformation from primary towards secondary fuels. So crude oil to gasoline and other oil products, maybe coal into coke, natural gas product to compressed natural gas even. That's more or less just a compression, but still something that transforms. It also transformed the physical sources like coal and oil and gas into electricity. So that is where your electricity sector lies. The same thing with your district heating sector if you have that in your system. It also describes your losses in your transmission system. So if you have transmission and distribution of either gas or oil pipelining, or for that matter the electricity grid, that's also where you put it. And then you also have the losses in your refining sectors between the primary to secondary fuels and all the losses associated with that. So it's not just a direct transformation, it is also from how much fuel to get to something else, and there are also some thoughts on imports and exports. In the transformation sector in Leap, one very important thing is the module order you have in your transformation sector. So demand lives on top here. That's where it is in the model branches and the model overview. The resources is down below, and that actually has a meaning in Leap. So the closer you are to the demand, the more downstream model you should have, and the closer you are to your resources, the more upstream model you should have. That means that Leap will start throwing errors and have problems calculating if, for instance, you would have transmission and distribution, which is here, this is the transmission and distribution losses of electricity. If you had that below electricity generation, and if you have oil combustion, for instance here, you need to have your oil refineries below that physically, because that is closer upstream or further upstream than your electricity generation. So that is a very important concept, that you have the order of your processes correctly. So the closer it is to the demand and the more is being used by the processes above it. That's the way it has to be. Now, of course, that also does mean, when it's like calculated linearly like it is here, that it does mean if you use electricity or consume electricity in your oil refineries, LEAP will not be happy about it, and it will actually take the results from the previous year if you do it in a linear fashion, which you might well do in much of this, depending. So how does the transformation module look like? How does the sector look? So you have the general category. This is basically just a name. We call it charcoal production. And depending on how you make it, but with most of them, you can define your output fuels, and actually you can have more than one. So this one, but you can have more than that. And that is, in this case, charcoal. Now, then you will also automatically have a folder called processes. And as it leads to, you can have a number of processes. This is especially prevalent in or relevant in something like electricity generation or district heating generation or something similar, where we have multiple processes that can have the same secondary fuel output or similar. But here you can see we have a process, and this process is also where we define the energy efficiency or losses depending on what we do. We also define some of the capacities of the specific technology we have, which does have a larger impact later on. Then when we have the fuels, which we can have more than one. We can have at least one feedstock fuel, but we can also have a number of feedstock fuels. That's also where we calculate later on in fuels the capacity for the feedstock fuel itself, where we have that. Also here in the charcoal production or the output in general, we can also have something like forced import and forced export included as well. We will get into that. We will show windows in a second. Auxiliary fuels, that's simply fuels that doesn't translate directly into, that isn't directly feedstock, but it's still being consumed. These will quite often be electricity, or maybe it's an oil for transport or something similar that is being consumed in this process, but doesn't count towards the efficiency of going from one fuel to another. And as you can see here, we have more than one processes, and we can have a number of them, of course. Now we can also have more than one output fuel from one sector. So for instance, quite often in something like the oil refining sector, we'll find we have a lot of oil products coming from the same, now they call just the process of the crude oil, but this is really a refinery for crude oil, and it only has one feedstock fuel, but it does have leads to a lot of different oil products. So that's also absolutely something you can do in the transformation sector. Then here you define not just the efficiency, but also the share of how much a liter or a energy amount of crude oil becomes gasoline. This is flight kerosene and other different oil products. That does also mean that depending on your demand, you can either have waste over of, let's say you have a large gasoline demand but almost no diesel demand, then this can be designated, or the LEAP model would designate this for export, for instance, if there just isn't enough demand in your system, but it has to produce it to produce the gasoline. So LEAP can take care of that, which is quite smart. Now here we have tried to add a new transformation module. So we have a number of different things we can choose. So either we can take a simple non-dispatch module, one fuel per process. That is the simplest form of making a transformation module. I will actually not recommend it. I think it's only applicable for very, very small systems like island systems, more or less. Otherwise, most module types are actually simple enough even. Of course, we can introduce cost and capacities. We can have another co-product. We can do that afterwards as well, but still. And then you can put in output shares. So this depends on if, for instance, you had the previous situation with gasoline, diesel, and other oil products. If this, with this tagged on, you force it to say that 10% of it will of crude oil will become gasoline, and 6% will become diesel, and so on, depending on your actual refinery. Otherwise, it will just take and make, say, if your 80% of your oil products demand is gasoline, this will just make the crude oil 80% into to gasoline. That might not be totally realistic, but it might instead, but it might be a good theoretical exercise to do. In terms of capacities, this has an important role to play because it is one of the limiters for our self-production or self-sufficient production that's not necessarily just hinged on resources. So if you have this on, you are also taking into account of the capacity of your actual transformation module. This is again where the step function, if you add capacity to your transformation, is really, really useful. Now here we also of course have energy efficiency, which can be defined in different ways, either as heat rate, losses, or efficiencies. They come down to quite the same, I think, but it's just different ways of describing it. So in this case, I'm just trying to put in the simple non-dispatch module to see how it looks like and show you. So in this case, you can see I made here my process below, which is my test symbol process. And you can see the only thing I can do is I get a test process. I can make it right away. I can only make one, I think. Actually, I think in process I might be able to do more. And I just get choose a feedstock fuel right away. Then up here in my process efficiency in my window, I can then choose my output fuel, and that's it. No capacities, no cost, no considerations on anything else. I just need to make some fuel into another fuel because I need it in my model. That's what it is about. Okay, and then we zoom in on that. But yeah, but the important part is you have to click on the test process to have this process efficiency window open, and I think you have to be in your current account scenario, which is a little bit janky to be honest, to be able to choose your output fuel, which is another good reason for never using this. I think this has not seen a lot of dedication because it's rarely used because it is too simplified simply. But I just wanted to show you if you want to set up something quickly. Now, if we then set up a non-simple fuel, and here I also choose to use capacities because it has some interesting consequences. So if you try to look at that, it looks like this. We have the non-simple. So here in my non-simple, I can go in and in my properties, choose my different, choose my output fuel, go in, add processes afterwards. I can put a name, and I can choose my first feedstock fuel. I can choose further after that, but I need at least one, so I just have it in this wizard. Here I'm just choosing, I think, coal or crude oil. Sorry. So here I'm just making diesel. And I can then add another process if I have a different process. Now I just choose one that was offshore process. I'm not sure if that's really relevant. Now under each of these, I have my feeder fuel, and I can choose also my auxiliary fuels. So in this case, I just choose electricity, quite realistic. I can do the same thing in the other. Now up here in my different processes, I can then choose a few rules. So you can see I have a dispatch rule already, a process share, and process efficiency. Now the dispatch rules is just really the order of what I want or how my dispatching of these two systems are, but they are quite simple. So here I just say that they're the same as the percent share, which is something I'll just put in the process here. So I can say, well, of my basically my capacities are I can put in these different shares of that. Now the capacities have an interesting side effect. So here I have gone into my energy balance. And I've done the simplest version I can of this. This is for 2040 from a baseline scenario. So what you can see here is my imports of my oil products, meaning diesel, gasoline, and so on, secondary fuels, is actually quite a lot higher than my import of my crude oil. Also, it is quite a lot bigger than my production of crude oil, which is none, and the same thing with my oil products is none. But quite a lot of places you have a large production of your primary fuel, in this case crude oil, then and then you transform it yourself to your own oil price, and that's actually what happens here too. So you can see now we can talk about having transformation, which is this part. And down here, that's demand. And then the production imports is actually resources, but we'll get to that next video. But what we can actually see here in our total primary supply, which is again is import, we spend all of that in our oil refining sector to produce oil products. So we actually produce quite a lot of oil products. But at the same time, we import them directly. And we can see the total demand of our oil products minus some transformation losses and so on is actually quite high. So what is really happening here is that we both import our crude oil that we can then transform to our secondary fuels, but the capacity is actually limited in our transformation part. So that's a transformation capacity. So that's a transformation capacity limit that causes the system to act in this way, where we both import crude oil to transform it to secondary fuels, but we also directly import a lot of secondary oil products. So just because we don't have the necessary refining capacity, if you were setting up the refining capacity, this would disappear. This import of secondary fuel would disappear. So that's only due to a transformation capacity limit. Had it been a resource capacity limit, well, that's what we have here. We have no production of crude oil, so we have to import all of it. So that's what happens because we have a resource limitation, but we'll get to that next video.